Rain in RenderMan Studio. Rather RenderMan for Maya. Now, it's about 10 o'clock and I just got back from San Francisco visiting some friends who are in town for GDC, and I am tired. But I am giving this talk at Berkeley on Friday, and I've got to rehearse it, so I'm recording it, and let's see how well I do. So, if you're using RenderMan for Maya, first thing you need to do is set your project. If you don't set your project, you're in for some bad times. We're going to do Small Tropical Island. Set our project there. Next thing we'll do is load our plugins. If we go to Windows, Setting Preferences, Plugin Manager, hopefully you have the latest version of RenderMan for Maya, which in my case is 21.3, but this will be an ever-increasing number, so make sure to always have the latest and greatest. We are constantly fixing bugs. Great. Now I highly recommend saving your scene before doing anything else. RenderMan for Maya will save lots of files in a folder with your scene name. So if you have a lot of stuff in Untitled, that's bad news. I'm going to create practice_c.ma. Great. We have our project set, our plugin loaded, our file saved. Now let's start importing some geometry to work with. I found a lovely small tropical island on high-end 3D, which you're all welcome to find as well. There's the OBJ. I'm going to import that. Let's see what we get. Something clearly not at the origin. I'm going to hit the wrong button. Control A to frame everything, and F. And yes, there's our island. So, as wonderful as this vegetation is, I'm going to limit today's demo to just the rocks and the ground. So we're going to call that good enough. Alright, let's shade this guy. Let's hit save. So first, let's just go over how to render in RenderMan for Maya and see what we start with without doing any shaders, any lights. So if you go into the RenderMan menu, there's a render button. If you hit the option box, you actually have the option to render to display view or it. It is the image display tool that comes with RenderMan for Maya. I recommend using that. You can bring up it by hovering over that little eye icon in the RenderMan panel, and that will bring up this lovely UI. One of the fun things about this is if you go under Window, there's the option to always stay on top. We can keep this window on top over Maya at all times. That can be useful when iterating quite a bit. So, I'm just going to save that, and let's render using it. And we should see some pretty horrible looking geometry there. Alright, that is bad. Before we get into any lighting or shaders, let's just look at the quality of the geometry and those polygonized shadows. They're polygonized because, well, most models start as simple polys. RenderMan is meant for feature film rendering, so you know what, in feature films we mostly use subdivision surfaces, so you guys should too. Select your geometry, hit 3, and ignore Maya's warning that we were creating a lot of extra geometry, because you want to know what? We can afford it. We want this to be smooth. So let's render again. I'm just going to hit R. I guess that doesn't work. Anyway, hit render again. And we should now see some very smooth geometry. Brilliant. All we had to do is hit 3 and we improved our scene quite a bit. One way to compare one render to the last using RenderMan for Maya's image display tool is to go to Window, open up the catalog, and we now should be able to switch between, this just keeps, itinerary of every render you've done. And yeah, you can see, just hitting 3 got us a lot further. So great. Model is final. Now let's light and shade it. Lighting will be very quick. I am not a lighter, so I do the easy thing, which is to do image-based lighting. I create a dome light, load a really nice high dynamic range texture, and then I call my lighting done. So to create a dome light, you right-click on the little light icon and select dome light. There we go. There's our dome light. Let's go to the attribute editor, one of these icons. Great, there. So we're going to load a color map. I just so happen to have copied over desert.env, which actually comes with RenderMan for Maya. And I just copied it over. Brilliant. Alright, now that we have a lovely dome light, let's go to our resolution gate and try to create a pleasing composition. Wonderful. Look at that arch revealing a little bit of sky. There's maybe too much hill in the background there, but you know, before we judge, let's send off a render and see what we have. Wait for it. How awesome will this render be? Well, the lighting on the ground is better, but we're not actually seeing the sky. For most professional lighting, you know, you're not literally going to use the texture on your dome light as the background. You know, that's why we have compositing. But for amateurs like me, you know, who just wants to make a cool looking image really quickly, you know, we want to actually see that dome light. So if we go here in the attribute editor with the dome light selected, make sure to check camera visibility. Next time we render, we should see some lovely pixelated environment map. Alright, that is great. And clearly we're seeing too much desert, not enough sky. At this point, I'll bring up the concept of an interactive viewer. Now you might be asking, why don't these two match? I don't know, but that's life. We just want to adjust it so we see some sky. So what I'm going to do is actually start an IPR render, which is interactive. That allows us to adjust lights and materials live. So in theory, with that dome light selected, we hit E, get that rotate widget. I can take the RX and just rotate that back, and boom, we see more sky. Interactive rendering in its finest. Good, let's stop that. At this point, I'm going to save our scene, and that is it for modeling. That is it for lighting. Really, the focus of this demonstration will be procedural shading using geometry-driven detail. So with that, let's shade the rocks, shade the ground, and make this look great. So because we're going to do shading, I'm going to click on the Hypershade shelf button right there, which brings up, I think this is Hypershade. Great. So if you in Hypershade, if you hit Tab, you can just start typing, and just like in Houdini, start bringing up some cool nodes. My favorite shader to use using RenderMan is the layer surface. In a very simple demo, we'd be starting with a you know, a single material shader, something like a PXR surface or PXR Disney. But really, the way I like to shade, and you know, many people do in industry, is layered. So I'm not even going to start simple. Let's just start right with the layer surface and know how to work with this. So let's hit enter, and boom, we got a whole bunch of nodes. How about that? So first thing I like to do is name these nodes. You know, when you're working really quickly, it's easy just to leave everything in its default names. And you know, this is a tutorial video. This is probably not what you want to see, but let me convey. Name your stuff so you remember what it is. So I want this layer surface to be for the rocks. So I'm going to call this layer surface rock. Layer 1, I want to be our I don't know, stone layer. And then layer 2, which is layer on top of it, I want to be dirt. If we select the layer mixer, we should have a little drop down for each layer, and you'll see that sure enough, we have dirt and layer 1. Not sure why it doesn't say layer stone, but suffice to say dirt is on top. I'm going to turn dirt off for now. We're going to fill that in later, but I like just creating that up front because anything interesting is going to have dirt on it. Okay, so now let's work on connecting some things to the stone. So at this point, one of the benefits that happens since RenderMan 19 is having some pretty good interactive rendering. So in theory, we should be able to do quite a bit of shading while the render is still going. So I'm going to kick off an IPR, and I'm going to put this in the upper right hand corner of the screen and just let that keep rendering as we change attributes in our shader. So if we select the stone, maybe let's not have it quite in the upper right hand corner, maybe right there. Go to diffuse. If we change that color, maybe the stone will update. Well, it won't because we haven't actually bound our material. Stop your interactive render, select the stone, right click on layer surface rock and go to assign to viewport. Now start your interactive render. Yes, hopefully I edit this video, but chances are I won't have the time. Okay, back to the stone. Now we should be able to change our color and get some wonderful interactive preview. So for now, I'm just going to leave it roughly stone colored. What I want to do is introduce you to creating patterns and how to connect patterns to materials. So I'm going to start by creating a fractal and driving the gain on the diffuse, which is an overall value brightening or darkening. So I'm going to create a PXR fractal, which is going to be the basis for so much of our procedural shading. Fractals are infinitely useful. So one thing we can do, just as a little exercise, is connect the result F of that fractal to diffuse gain. And hopefully we'll see some kind of fractal pattern. Now, fractal is based off of world space scale, or at least it should be, or often is. So as you can see, as this resolves, that's a pretty high frequency fractal. We're going to want to tune that a bit so we get more variations. Like that looks very spotty. I want big blobs as well as fine spots. So one of the first things I do to make sure a fractal is the correct scale is make a connection to the manifold, which is the 3D space in which the fractal operates. So I'm going to create a PXR manifold 3D. And for coordinate system, I'm going to do world space. You know, in production, we often create a space per asset, like, you know, terrain space or model space that we use. But for expedience, you know, unless this thing is animating, world space is pretty good. I bet a lot of people are cringing who know better. But for now, I'm going to use world space. And I'm going to connect the result to the fractal. And it knows, if we select the fractal, that boom, PXR manifold is there. Now, one of the things you have on the manifold is scale. Clearly, that's too high frequency. There's too many little dots there on that fractal. So let's just go from 1 to 0.1. You know, take it down a tenth, and wow, that is dramatically different. One thing I like to do is lower the scale until the blobbiness of the fractal is roughly like half a blob per object. This is just a really rough heuristic. So this is too many blobs per object. So I'm going to create 0.05. Have that. Alright, it's maybe 2 or 3 blobs, maybe 2.5. There we go. And I do that because I want the lowest frequency to still be interesting. Because one of the cool things about a fractal is it's many layers of noise. 6 layers in this case. And each layer is higher and higher frequency. So, you know, I like the lowest layer to look good. And then from there I tune the higher layers. That's just how I work. So to bring up the influence of the higher frequency layers, I'm going to increase the dimension from 1 to 1.2. We can see we get a little more, you know, crisp and stone-like detail. Maybe 3.5. Now, you got to wait for the IPR to go a little bit to see the fine detail. And already you can see that's breaking up those lower frequency blobs. I mean, that's pretty good. If you want even more detail, you can crank the layers above 6. I'm going to do 8 just for fun. But there's diminishing returns with that. And, you know, there is a cost to each layer. So, you know, 6 to 8, 10 at most is probably pretty good. Some people who know better might have better, you know, opinions. But that usually is what I do. So, alright, that's looking a little more stone-like. But the contrast is just a little bit washed out. I'd love to increase that a little bit. Few ways to increase contrast. One of my favorites is a PXR Remap Node. Let's just drop this guy in here. Remap is just essentially a way of increasing contrast, and there's a number of controls to do that. I'm going to connect you have the option of doing result F or result RGB. I like to keep it RGB until the last minute, and then I change it to F if it needs to be. So I'm going to do input RGB. and then just take the results R and connect it to diffuse gain. Again, I'm doing that just because diffuse gain is a float, and we can only connect one number. So there we go. And by default, PXR Remap does absolutely nothing. A few ways to increase the contrast. My favorite ways initially are bias and gain. Those are like gamma correction. So you're not actually clipping anything off, but you can use input min and input max, which does some clipping, and sometimes that's more intuitive. Alright, I'm going to try gain. I always forget which one does which, and just see if that makes the contrast better. Boom. Lowering that seemed to do some nice wonders there. Look at that. Already looks more like stone. Maybe drag it a little further, but honestly, even that first drag looked a lot better. So, alright. I'll call that stone, at least in the color. But even though maybe that's acceptable, I want to keep showing you guys some more things. So before we call that a day for color, I want to show you guys how to use a rounded cube map, which is another way that is really good for adding detail procedurally to models. Like a fractal, rounded cube map is based on the 3D shape of the object, not UVs. So it's really easy to move this from one object to another object. It's scale dependent, not UV dependent. To show you how to do that, the node that is going to read this texture is called a multi-texture. Multi-texture can, in theory, handle multiple textures, but the way we almost always use this is to connect to the multi-manifold a PXR rounded cube map. It's called a rounded cube manifold, a multi-manifold, because really this is actually sort of multiple UV spaces, 3 to be precise, 3 projections. So we're going to project along 3 axes and blend the textures, so hence multi-manifold. And we're going to connect the result of that to our multi-texture. It's also good practice to use another PXR 3D manifold, just like we did with the fractal, so we can easily set our scale. Again, I'm going to set it to world space, and let's connect the result of that to the... Thought there was a manifold. Oh, never mind. Pretend I didn't do that. Looks like rounded cube itself has a manifold built into it, so we can set the coordinate system to world. How convenient. What's not convenient is the size of that node. Anyway, let's load a texture. So I recommend, if you guys are looking for good procedural textures, the Pixar 128 library. You can download it from the resources section of the RenderMan community website on Pixar.com. And there's a great number of tiling textures here. Under stone, we got a bunch of fun ones. I kind of remember granite being kind of fun. I actually, yay for Maya showing what the textures are. Actually, rather gray marble. This is really cool. I actually like the bump textures. These are intended for bump mapping, but they do great for color as well, especially the grayscale ones, which I tend to like. So I'm going to load that guy. And for fun, I'm going to connect this to the diffuse color. I'm going to go to result, RGB, connect it to diffuse color, and let's see what we get. Now, just like fractal, there's a very good chance the scale is going to be way off when you start with. And in fact, it almost looks like we created some kind of brick. See these little striations? That's that texture tiling over and over and over again. So we are way off on scale. We are way too high. And it's actually not a bad idea. Whatever scale you came up with fractal usually works pretty good with rounded cube. So let's go ahead and just paste that in. See what we get. Hopefully we see some lines in there. And actually, yeah, that's looking pretty cool. We got some cool little white stripes here and there. I'm going to increase the... that almost looks perfect. But just to show you what different scales look like, let's go up to 0.1. And we should get a lot more high frequency detail. Well, to tell you the truth, it's kind of hard to tell, isn't it? To make this obvious, and also because it's not a bad idea, let's go create a PXR remap and just see what the effect of that texture is. Let's make it overly obvious and then dial back from there. So I'm going to create a PXR remap, connect our result RGB to the remap, then the result RGB of the remap to the diffuse color. And now, I guess I'll do the same thing. It looked like lowering the bias seemed to increase the contrast. Well, that certainly did something. Alright, looks like we had a few lines here and there, and yeah, it's pretty high detailed. Let's lower the let's lower that 0.5. Ah, there we go. Now we're starting to see detail at the scale. It's really tricky with rounded cube map. You get kind of seamless, texture mapping without UVs, but unless you get the scale right, it's really hard to see those details. So that's cool. But actually, to tell you the truth, I think we went way low on the bias in the remap. Let's maybe go the other way. Nah. Oh, sorry, I meant gain. Gain is usually what I do to increase contrast, not bias. That being said, that is getting a little bright. So one other thing we can do in the remap is if you want to take just the overall, darken a little, you can take the output max and say 0.8. Like, dude, just never get above 0.8, please. And that keeps it from getting too bright. And I also think, I gotta say, that fractal is darkening a little too much, so I'm gonna go back to that fractals remap, maybe make the output min 0.2, so it's not darken quite so much. Take that back, 0.1. And maybe the output max, lower just a little bit, 0.95. Sorry, I'm noodling. You gotta be careful when you're doing a demo. You just don't want to noodle too much. So honestly, let's call it rock. Totally fine. All right. So at this point, we should probably talk a little bit about displacement, because if you're gonna shade rocks, you're gonna want to make it nice and rocky looking and have that good texture there. And this model is really smooth. So no matter what we do with the color, unless we actually at least change the normal, or better yet, move points around, it's not really going to look like a rock. So let's talk about displacement. To use displacement, well, first thing I'm going to do, now and then, make sure to stop your IPR render. This doesn't work forever. At some point, things get out of whack and you got to restart it. And it's also not a bad idea to save your scene now and then. So I'm going to stop the render, save my scene. Now let's talk about displacement. So to do that, we create a PXR displace node. There we go, PXR displace. And unlike most patterns, PXR displace looks like a shader on its own right. It's got a shading group and displace node. That is because, well, it is a shader. It's a shader that moves the points or the micro polygons of an object around before the final render goes. So it's kind of like a shader that runs in the pre-pass. As a result, you cannot change displacement while the IPR render is going. I don't think that's always going to be a restriction in RenderMan. I'm pretty sure the engineers are working on overcoming that limitation. But at least at the time I'm creating this demo, I am under the impression that we have to kind of create displacement without the benefit of live render. So let's do this now, but then later we're going to get back into IPR rendering to make it really smooth. So really quickly, displacement, I would honestly just take whatever you are doing to vary the color, plug it into displacement, see what it looks like, and then go from there. It's really just controlling the, how much we push the points in or out. So I'm going to just create a PXR mix node, and I'm going to mix together our fractal and that we're controlling the diffuse gain and the rounded cube map, and just start from there. So I'm going to set the result RGB, go to color 1, and then here, get the result RGB, go to color 2, the mix, Let's do 50-50. And then we can play around and see what we really want to control the height of the object. And not a bad idea. I would almost always go through a remap. I mean, you can see I love these remap nodes. I'm just going to put that in there. Again, we're not doing a live render, so I want to make sure it looks, the topology of the network's good before we hit render. We're going to connect the results R. And you might be seeing me doing this very casually, but just remember, some parameters are RGB, some are float. If you're going to connect to a float, just grab whatever color channel you feel is best. And if this is black and white, so they're all the same. So I'm going to connect that to disp scalar, which is scalar displacement. Looks like it is enabled. And let us go. All right, so let's call that pretty good. One of the things we need to do is to wire this up to the rock, we need to take the out color, yes, the out color, and wire that into the displacement shader of our layer surface. A little weird, but there's legacy reasons why RenderMan works this way, and just get used to it. So let's see what that did to our surface. One of my guesses is not very much. It all depends on, again, world space units. Depending on how big your scene is, you might need very large displacement gain or very small. So if we take a look at the difference between them, it kind of looks like we dilated the surface a little bit, but certainly we're not really seeing the rockiness. So if we want to make it obvious, one of the easiest things to do is just crank the gain. This is not a great solution, but for now, I would do that. And this is actually going to illustrate a problem. You're going to see what's called patch cracking, which is where the displacement exceeds the bounding box of the underlying object, which you need to manually pad. And see those black surfaces? Those are patch cracks. Now it's definitely looking rockier, so check on the rockiness. That's looking cool, but it's getting a little bit bloated and dilated, and we have patch cracks. So to remove patch cracks, there's a nice, lovely historic attribute under RenderMan attributes called displacement bound. This should be set to roughly the maximum amount your displacement is. Yeah, anyway, hopefully this parameter goes away at some point too, but for now, just know what your network is doing. Gain is 10, we should probably make our disp bound 10. That should make the cracks go away. So while that renders though, let's think about the problem where it's looking a little bit bloated. You can displacement, especially scalar displacement, occurs along the normal of the object. You can displace, positively as well as negatively. So we just really want the contrast between, the different portions of the rock. We don't necessarily want it to get thicker. So one thing we can do in that remap is remap it so that half of the values are positive and half are negative, and maybe we can roughly keep the original silhouette. Sounds cool? All right, let's do that. So let's go to PXR remap, and one of the things we can do is say output min. You're going to go to negative 0.5. Maybe output max, you go to 0.5. We'll see what happens. Now, what often happens is dilation is actually often less objectionable than the artifacts you get by actually eroding the object. Things that had contact no longer do sometimes. So you got to be really careful with negative displacement. But I don't know, man. That actually looks pretty good. Yeah? Yeah, all right. Like I said, don't noodle forever. Once it looks good, kind of move on. So that's a good reason to hit that and hit save. All right, at this point, I'm going to take a sip of tea, herbal tea, because it's late at night. And let's talk about how to shade the ground. Now the ground, I'm going to just do in a similar way. I'm going to create a layer surface and with some dirt, and I'll just do it really quickly so we can move on to the dirt, which is where it gets interesting. So I'm going to create another PXR layer surface, and looks like I have my dirt actually below, and since I'm going to share the dirt, I'm going to actually move this down. So excuse me while I reorganize my node graph in this little bit of screen real estate I have. It'd be nice to have much bigger monitor, or tons of monitors. At work I do, but I'm at home. All right, so here's a new layer mixer we have, and this is what I'm gonna call this layer surface ground. And I'm going to take the first layer, and I'm gonna call it, I don't like to say ground again, so I'm gonna say, I'm gonna just call it ground, sorry. I can't think of anything more creative. But layer 2, we want to be dirt. So one of the things I'm going to do that's actually interesting is, this is not always the greatest thing to do, but at least initially, I'm going to share the same dirt layer between both these materials. One of the cool things that can do is allow us to kind of join the two different shaders together by this common dirt layer. It helps, what we say is seating one object on top of the other, is if they're joined by a common layer. So actually, you can delete that PXR layer 2. I'm going to drag layer dirt and connect it to layer 1. However, like we did earlier, initially I'm going to disable layer dirt until I put anything interesting there. But I'm getting this set up. I'm rigging this procedurally to look good. All right, so next let's select our ground and actually bind layer ground. Save that, and let's start an IPR render and take it from here. Let's see how much we can do live. Every version of RenderMan for my live render gets a little more stable, so hopefully this will keep going. So the ground, what I'm thinking is let's make the ground somewhat pale, like dry, and have the dirt not just be like, soil, but also have a little bit of moss and vegetation. So really dirt is more like moss. So I'm going to kind of maybe go to the diffuse color and maybe make this more dirt sandy looking. So I don't really want to tweak too much. So I'm just going to take my best stab at this. One cool thing about a live render is it's pretty easy, especially with the lighting, to see how it goes. So I mean, that's a start, but I kind of want to go more towards the green and lower the value a little bit and maybe a little bit more. Maybe desaturate it slightly. All right, let's call that our ground shader, and we'll add the vegetation through the moss. So it's always good to have a fractal. So as great as a color like that is, let's actually maybe instead of using a single color, let's use a fractal to mix between two. This is a pretty common practice. So I'm going to create another PXR fractal. Let's consider this a little bit of a review. Like before, dude, create a manifold. Do yourself a favor. Just do that early on before you end up having to fit it in later. Set the scale to 0.1, which I think was pretty good. Maybe it was something else, we'll find out. Go to results, pipe that in there. And now before we were connecting this to diffuse gain. I did that because it made a quicker demo, but we want this to vary the color of the ground. So instead of diffuse gain, I'm going to actually connect this to a mix that blends between two different colors. So I'm going to use a PXR mix node, one of my favorite, most simple nodes. I'm going to connect the result F of the fractal to the mix. And for now it's black and white. We'll fill this in later. So I'm just going to connect the result RGB to our diffuse color. All right, we can tell pretty early, well, our fractal scale is off. We want fewer blobs. So I think it was 0.25 was probably what we liked. That's not bad. I might actually go a little lower. I'm going to ground as a bigger object. I like to have, a little fewer blobs than that. So I'm going to 0.01, take it down by a fifth. Cool. So look at that. We got this nice smooth gradation. Might be worth raising the dimension a little. I often find the default dimension is a little low, and that just brings up the contribution of the higher frequencies in our PXR fractal. And okay, at this point, before we say that's good, let's actually dial in some colors. It's best to work in as much context as possible. So thankfully we have this color history thing in Maya. That's really cool. So it just remembered one of my colors, and I'm going to set that for both. And I'm going to make this one a little more saturated and a little lighter. And I'm going to make the other one a little darker and a little less saturated. And let's see what we get. I'm also going to maybe make the darker one a little greener. I just want a little bit of a, like what it has rained here at some point. So there we go. So check it out. Terrain shading on the cheap. That actually, now that the contrast is a little lower, I'm starting to think, let's raise that dimension just a little bit, a little more variation there. And it's tempting to say we should put a PXR remap, but again, you can. One of the problems with proceduralism is you can really go to town adding nodes, and sometimes more is less. So I'm just going to say, if you want no more remaps, that's our terrain. So note I didn't go over specular in this demo. We should probably have a little speck on the rock. But for now, let's keep it diffuse, keep it fast, and let's work on the dirt. So for that, there's a few ways to do dirt, but I tend to employ what's called geometry-driven detail, where I basically try to use the shape of the object to determine where dirt might accumulate. One great way to do this is using a PXR direction node and focus the dirt on upward-facing surfaces. So facing direction, facing ratio. Clearly I don't know the name of this node. So the facing ratio gives you basically the dot product of the normal and some vector. By default it's the camera vector. I'm going to pick a direction, and then 0, 1, 0 is world up, well, assuming your coordinate system is world. You do that, this facing ratio is going to tell you where the object faces up. So if we want to create some dirt on the upward facing side of the object, where it rains, where dust settles, we can use this sort of pattern. But first, before we connect this up, let's actually enable the dirt on our objects. So I'm just going to enable dirt on both of our layer mixers. This is going to get really boring really quickly. We just covered the world with grayness. Ugly. All right, let's instead make it a little more green. A little further on the green spectrum. That's looking kind of cool. Maybe a little too green. Let's go back to the yellow a little bit. All right, somewhere like that. Anyway, we can futz with the color a little more later. Great. So now what we want to do is use this facing ratio to drive the presence. So that's what this layer 1 mask is. It's basically how much of layer 1 you want. That's an opacity, and this facing ratio, just so you guys know, actually gives you a value between 1 and -1. 1 where it's facing the vector, -1 where it's the opposite. You do not want a -1 opacity. Good code should check for that, but I make no promise about the quality of, this. It's hard, as a programmer myself, sometimes you forget these things. So as the artist, make sure you click clamp, which makes sure that any value below 0 stays 0. So now it's safe to connect this to layer mask. So I'm going to take the result F, connect it to layer mask, and do the same for our other layer mixer. Connect result F, zoom to layer mask. Alright, and now we have a little bit of dirt accumulating on the upward facing side of our, and it kind of just unified it. All of a sudden we went from having 2 materials to roughly 1. Now, this is a bit of a boring pattern. We're gonna spice this up a little. But one thing you can do is, this is a little bit too much, kind of dirt or moss on everything. We can play with the gamma. I think lowering that has the effect of tightening basically the facing ratio, basically raising it to I think 1 over the gamma. So 0.4545, a gamma many of us know and love. Should give us, kind of a cooler result. And, we might want to lower that a little. It's like getting too opaque in some areas, but that's where our other geometry-driven detail is. So PXR facing ratio is cool. Just based on the shape of the object. Has nothing to do with the UVs. It's easy to generalize from object to object, but it kind of just goes everywhere willy-nilly. It doesn't respect anything but the orientation. Another pattern that is super useful for placing detail is PXR dirt, which uses a combination of occlusion and curvature. And now this is not a cheap pattern. So this is a pattern that needs to be baked, but it is very important for look development. And I'll show you guys how it works. So I'm going to create a PXR facing ratio. No, that's just what I created. A PXR dirt. Alright, and in this PXR dirt node, I am, basically there's a setting for outside, inside, both. That's whether you're doing occlusion, curvature, or both. For now, let's just leave it the default as outside, which means this will give you occlusion. And I'm just going to, well, first I'll just connect this, and then I'll show you how to mix it together. So I'm just going to take the results R of this, connect it to layer mask, and do the same for this layer right here. And now what you'll see is the render gets a lot slower. That is because, again, I said this is a pattern that should be baked. What it's really doing is casting, in this case, 4 rays in each direction, and figuring out how many hit something, and that's how occluded it is. So you can see we get a lot of moss sort of in the shadows. Now 4 is super low. I would go no lower than 16, and you can see how this is making the render crawl. But you can see we're starting to get a nice concentration of dirt in the shadows and crevices. Now it's doing an infinite distance for the rays, so if the ray ever hit anything, it's being occluded. So this is about as soft as the pattern gets. If we give it a max distance above 0, it's going to start to use a fixed distance, say go 10 units or so, and that will make it a lot crisper using a max distance. So it'll sort of concentrate the effect just around the contact points of the objects. Maybe 20. And you can see it starts to spread a little bit. So you can actually see in the shadows right there, it's getting a little bit greener, as well as in the cracks of the rocks. So this is another cool geometry detail. You can do both. You can do outside, inside, and both. What both means, it will not just shoot rays out to see how occluded. Basically, outside measures concavity, whereas inside measures convexity. And actually, with all these round objects, we have and things like that, we're going to get quite a bit of nice convex detail. So that's kind of cool. That gives us a lot on the rounded edges there. And I'm going to say, just to show you really what the signal looks like, let's bump it up to 64. And this will definitely illustrate why you want to bake this pattern. At 64, for every ray hit, that's evaluating the pattern, it's going to shoot 64 other rays just to figure out how occluded it is. This is bad news. Even if you have the render time, I don't recommend ever not baking PXR dirt, because we're often going to take this pattern and threshold it, which is going to make it even harder to denoise. So yeah, at this point, this should give you a clear reason why we want to bake this pattern. But it looks so cool, doesn't it? So with that, let's talk about baking. I think that's enough for this. Will be before I guess we finish this, I'm gonna cancel that. We're gonna want to combine these two, so I'm gonna do a PXR mix, And I'm going to mix facing ratio. Well, here's a fun thing. So mix is it takes an RGB as well as, takes two RGBs and mixes them, whereas facing ratio gives you a float. If you ever get stuck with data types, there's a PXR2 float 3, and that will let you turn that facing ratio from just an R to an RGB, and that's a little cleaner than the alternative. So I'm going to combine these two. And let's do a 0.5 mix between them. And let's see how this looks. And I'm going to call this the end of part 1 of this demo, which is before we bake the PXR dirt. Sorry, look at the result RGB, layer mask. Sorry, result R. Layer mask is a float value. Tell I'm losing steam here. All right. Moment of truth. Will this look actually good? It's going to look a little washed out. I'm actually thinking beyond this, we'll probably want to do a PXR threshold to increase the contrast. But at this point, once you add the PXR dirt to your network, you really need to bake it because it makes all iteration just slow down. I mean, this is not a great situation if your live render is taking this long to update. Fortunately, as you'll notice with this live render, as soon as it completes the first packs, or at least has one sample per pixel, each pass after that goes a little quicker. But now this is getting really hard to work with. So thank you for watching this portion of the demo. See part 2 to talk about how to bake this, and get this, we're going to start adding grass based on the baked PXR dirt signal. So wherever we have green right here, not only will the color be green, we're going to grow some grass. How about that? All right, thank you for watching. Time to stop this recording.